So today we have a geometrical problem. It looks easy, right? But it's not that easy to prove. First of all, let me tell you the description of this question. So it goes like this way. Take a circle and in that circle draw its diameter. Now because of the diameter, the circle would be divided into semicircles. In the upper semicircle, draw a circle in such a way that it is tangent to the circle and also tangent to the diameter. Now at the point where it is tangent to the diameter is divided into some length. Let it be A and B respectively. And also we can see that we have two tangent points. Draw a line segment joining these two points, okay, and give this line segment a length x. Now because of this setup, there comes a beautiful relation between x, A and B, and that is given over here, and that is the main motive of this video, that we need to prove that 2 upon x square would be equals to 1 upon a square plus b square, where x, a and b are this particular pattern arranged. Okay, now you can take your time and try to solve it. Okay, now let us begin with the solution. So first of all, let us see the question over here, zooming it, and think what should be done. The first thing that I can notice is that I have two circles that are tangent to each other. So first thing first, we will use this particular theorem. It just I name, no name is there, just let us say that two tangent circles. There is no name, or else I don't know, but let's call it two tangent circle theorem. And it says like this way: if there is a circle and there is another circle, and if they both are tangent externally, or if they are also tangent internally, a beautiful things come, and that is the center of the two circle and the tangent point will be collinear. All these 3 points would be collinear, means a line joining the two center will be a straight line passing through the point of contact of the tangent. And similar goes for the internal, the center of the bigger circle, the center of the smaller circle, and the tangent point. All these 3 points would be collinear. The first thing is this that we are going to use. So we can see that this particular circle is tangent to the bigger circle at a point over here. Hence, if first of all let us mark the centers of these two circles, let me just remove x for a while and write it over here. Now, if I just assume the center of the smaller circle over here and center of the bigger circle over here, what I can do is that I can draw a straight line such that it will be collinear over the tangent point, over the center of the smaller circle and the center of the bigger circle. Okay. Now, as we have the length A and B, the thing is clear that the diameter of which circle, the diameter of the bigger circle, let us just call it diameter of big circle, is what? It is going to be a plus b. And if this is the diameter, then what can you say about the radius? It would be going a plus b upon 2. Also, let the radius of smaller circle be equals to r. Okay, so we have just seen that what we have done. Let me just remove this for a while, or else let it be there. I'll just use this symbol, that b is from here to here and a is from here to here. Okay, now look carefully that this is the center, hence the length from here to here would be equals to a plus b upon 2, and similar goes for this way, a plus b upon 2. But in the middle we have a point where we have a length a, hence the remaining length from here to here would simply be a plus b upon 2 minus a, giving us b minus a upon 2. This is necessary and we'll just use it. The second thing that we are going to use in this question is that uh, tangent line and radius meet at 90 degree at point of contact. This is the second theorem that we are going to use, and it is also simple. We have all learned it in school, that for a circle, if you draw a tangent, let it draw properly. If you draw a tangent, then if you draw the radius and the tangent will meet at 90 degree. Okay, this is the radius, this is the tangent. So in our diagram we can see that this is the straight line that is tangent to this particular circle, and as we have marked the center, let it be O and let this be P. So from O, if I drop a perpendicular, it would ultimately form the radius, and as we have just assumed that let the radius be smaller of the smaller circle, let it be R. Okay, now look carefully. At this particular point was the point of contact, let it be something like T. So from O to T, this particular length is the radius of smaller circle, hence it would be R. But the length, wait, now the length from P to T was the radius of the bigger circle, hence it was A plus B upon 2. Therefore the remaining length OP would be equals to what? PT minus OT. So the length OP would come out to be A plus B upon 2 minus R. This is the length of this particular line. Okay, so this was some setup done. Now let us talk about what is to be done now. So look carefully, we have formed a right angle triangle over here, this yellow one I am marking. Let me just increase the thickness so you can see. So look carefully in this yellow triangle that we have just formed. Let me draw it outside the diagram. So in this yellow triangle, first thing that we can see is that it is a right angle triangle. The height is r. The hypotenuse rule is played by OP, whose length we have just found to be a plus b upon 2 minus r. And this was done because of this theorem that we have discussed, that is clear to you, I guess. Okay, now what about the base? So look carefully, in the starting only I have just mentioned that this length is equals to what? B minus a upon 2. Okay, now we have a right angle triangle. The first thing that we comes to our mind is to use the Pythagoras theorem, not phy, it's pytha. So Pythagoras theorem, let us use that. So the height square means r square plus the base square, that would be b minus a upon 2 the whole square, will result in the hypotenuse square, that is a plus b upon 2 minus r the whole square. So therefore r square plus b minus a the whole square is, now we have three terms basically over here, but what I will do is treat this as a single term and r as the other single term. So we will have a plus b upon 2 the whole square plus r square, then we'll have negative 2 times a plus b upon 2 into r, and clearly the 2 and 2 will get cancel out. Okay, and also we can see that r square and r square will get cancel out. So finally we will have b square plus a square minus 2ab upon 4 is equals to a square plus b square plus 2ab upon 4 minus r into a plus b. Shifting the terms, r into a plus b will result in, common denominator would be 4, a square plus b square plus 2ab minus a square minus b square plus 2ab. Cancel, 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 cancel. What we'll have is 4ab upon 4. 4 will get cancelled out, and the r a plus b will go in division. So hence r would turn out to be ab upon a plus b. So it is also a nice relation, that is what would be the radius of this circle that has been fitted in such a way between the circumference and the what we say the diameter. Okay, let me just introduce a box over here. It's not working. Let us go with the hand only. It is also a nice relation, that what would be the radius of such a circle fitted in a manner. So just now we have got the radius of the smaller circle in terms of a and b. Now let us move forward. So what I think is, do we need to clear the diagram, or let us make the diagram again now, because we are going to have some different kind of setup. So first thing that we need is the circle back. Now we need a diameter drawn, then we again need a circle such that over here. Oh, let it draw it clearly. What is happening? Yes, yes, beautifully done, and sorry for the time it took. Now what we were already having was the length from here to here as a, the length from here to there as equals to b, and this particular length was equals to x. Now what we will do is join this particular point over there and this particular point over here. Now first thing again we can see that is the theorem from the previous video would be again used, not from the previous video, generally from your school also, and that is angle inside a semicircle. Angle inside a semicircle is always 90 degree. Now what it says that is inside a semicircle, if we draw a, sorry this is still on. Okay, so what does this theorem say is that in a semicircle, if you draw a triangle such that the top touches the circumference, then that angle would always be 90 degree. Hence, this particular angle over here would be 90 degree. Okay. Now what we will do is take the length from here to there as some variable and let that variable be equals to y. Okay. And let this particular angle over here be equals to alpha. So clearly from a right angle triangle perspective, we can see that the value of cos alpha would turn out to be, base is y and hypotenuse is a plus b. Now let us use my favorite theorem, and that is the cosine rule. Now first of all let me mention what is the cosine rule. So cosine rule says that if there is a triangle, no matter right angle triangle or acute obtuse, and if you have angle theta and the sides are A, B and C, then the value of cos theta would be equals to a square plus b square minus c square upon 2ab. You can see that we have to take the squares and add of the adjacent, subtract the square of the opposite, divide by 2 times the product of the adjacent sides. Okay. Now in this triangle, which triangle I have to take is, let me just highlight that for you, this particular triangle. Okay, you can see that it contains the angle alpha, and also the sides are very nice. The opposite side is x, the adjacent is y and b. Hence let us apply the cosine rule. Now this was from right angle triangle perspective, the right angle triangle perspective. Okay, now from cosine rule. So now from the let this be clear. Now from the cosine rule perspective, we can see that cos alpha would turn out to be, what would be, cos alpha will turn out to be y square plus b square minus x square divided by 2yb. As the LHS part of these two equation is equal, let us compare the RHS part. So y upon a plus b would be equals to y square plus b square minus x square divided by 2yb. Hence cross multiplication will give 2y square b equals to y square plus b square minus x square, and the division will have a plus b. Therefore x square shifted on the other side, so x square is equals to y square plus b square minus 2y square b divided by a plus b. Therefore x square minus b square multiplied by a plus b is equals to y square common a plus b minus 2b. Hence finally x square minus b square multiplied by a plus b divided by b minus a results in the value of y square. Okay, so now what we have is that we have assumed a variable y except for the three important variables. I have to tell you this always in the previous video from the past 2 years. I am, well, not past 2 years, like from past 2 years I am not making the videos, but 2 years back when I used to make the videos, I have to always tell you that always try to bring a relation between your substituted variables in the terms of variable that was already given. So y was a variable, and similarly r. Y and r were two variables that were substituted from our side, and we have just found its value in terms of a and b that was given, and similar for the y, we have found its value in terms of x, a and b. Okay, now let us move the things forward. Look carefully. This angle was marked as alpha. Wait, it's eraser on. Okay. Now look carefully. This angle is marked as alpha. Now we'll just mark these things in our main diagram also. So this angle was marked as alpha. Lock your eyes on it. Now let us move in this particular diagram. So what we have done over there was we have drawn a line like this way and marked this particular angle as alpha. Now look carefully. This is the radius from P to this endpoint, and so is the length PT. Hence this angle would also be equals to alpha, because let me just mention this theorem also. It is also simple. It says that angles opposite to equal sides of a triangle are equal. Angle opposite to equal sides of a triangle are equal. So basically in a triangle, if the two sides are equal, then these two angles would be equal. Okay. So alpha would be alpha over here also and there also. Then by exterior angle property, we can have this particular angle as equals to 2 alpha. So we already have this yellow triangle outside. So this particular angle has come out to be 2 alpha. Okay. Now look carefully. From this yellow triangle, can we have the value of cos 2 alpha? Yes, it's easy because it's a right angle triangle. So cos 2 alpha. So we can see that cos 2 alpha will require the base and the hypotenuse. Hypotenuse length is still in the terms of r. Let us solve that thing. So it says that a plus b upon 2 minus r. But the value of r we have got as ab upon a plus b. Hence a plus b the whole square minus 2ab means a square plus b square upon twice of a plus b. This is the value of the OP, that is the hypotenuse. Okay, so from this yellow triangle that you can see over there, the value of cos 2 alpha would be the base. What was the base? It was b minus a upon 2, and what is the hypotenuse? It is a square plus b square upon 2 times a plus b. So 2 and 2 will get cancelled out, a plus b will go on the top, hence b square minus a square upon a square plus b square. This is the value of cos 2 alpha. Now look carefully. Now we have this trigonometric identity that cos 2 alpha is 2 times cos square alpha minus 1. The value of cos 2 alpha is clear to us, and it is b square minus a square upon b square plus a square. It's a square plus b square no matter, 2 times. Now what is the value of cos alpha? So look carefully, the value of cos alpha in the simpler terms was y upon a plus b. So let us use that. Now it says that cos square alpha, so y square upon a plus b, and it would also get square minus 1. So therefore, b square minus a square, the negative one will become plus 1. Sorry, it has to be taken the LCM before. So just plus 1 upon a square plus b square. And that is twice of a plus b the whole square. Now look carefully, we have y square and we have already got its value. And it's over here. The value of y square what we have got is x square minus, sorry, x, let us see that together. It is x square minus b square multiplied by a plus b, and all of this divided by b minus a. Okay. Now on the left hand side, b square minus a square plus b square divided by a square plus b square is equals to, now here a plus b and the square will get cancelled out, so twice of x square minus b square. In the division we will have a plus b into b minus a. Here negative a square got cancelled out, we will have 2b square divided by a square plus b square is twice of x square minus b square divided by b square minus a square. Okay, 2 and 2 will get cancelled out, b square will get multiplied with b square minus a square. In the division we will have a square plus b square, and this result is x square minus b square. Negative b square will go over there, becomes addition, and a square by b square, and this is the value of x square. Taking the LCM on the left hand side, so we will have b square into b square minus a square, nice, plus b square into b square plus a square divided by a square plus b square, and that is equals to x square. In the numerator we can take b square common. What we will have is b square minus a square plus b square plus a square. Wait, we did a mistake somewhere. There's some mistake going on over here. The a should remain and the b should be get cancelled out, but it's not happening. What is the mistake that we have done? Let us see together. Is it somewhere over there? No, it's correct. Negative b plus b square is also correct. Where is the mistake? B square minus a square plus 1. The a has been removed, b square remained, nice. Then what we have was a plus b into b minus a, it's b square minus a square obviously, then would have plus b square. There's a mistake, where it is, can you guys see it? Is it somewhere over here? Let us see that. 2y square b upon a plus b is, okay, nice, x square gone over there, nice, a plus b, oh yes, it's a minus b over, not a b minus a, it's going to be a minus b. Okay, so substituting that value means this denominator over here, it's a minus b. So if it is a minus b, then we will have a plus b into a minus b, then we'll have a square minus b square, then we will have something negative b square plus a square. Okay, negative b square plus a square, negative b square plus a square, nice. Someone who have just seen that before would be thinking that there's mistake, but it has been corrected later on in the video if you are watching till now. So b square and a square plus a square means 2a square divided by a square plus b square is equals to x square. Now keeping the 2 in the LHS as it is, bringing the x in the division, so 2 upon x square results in a square plus b square, and in the division a square b square as a product. Hence separating the denominator we will have 1 upon a square plus 1 upon b square, and this was the relation that was to be proved. Okay, so hope you liked the video, and again sorry for the mistakes. Making video after long, mistakes occur, but as soon as the videos would come regular, the mistakes would go less and the questions would get more and more interesting. So this was my way to solve this particular problem, not solve, basically prove this particular relation. If you have any other way, you can do comment below, and if it's a type of a photo or a long solution, you can email me. The email address is in the description. Thanks for watching. Bye bye.